the volume of a liquid. There's a different procedure. Liquids are different than solids. Solids have definite shapes. How is a liquid different than a solid as far as its shape is concerned? Isabella? All right, liquid has different property. Are the molecules as close together in a solid? No, the molecules are a little bit further apart. So what happens if I took that cup of water and poured it on the table? Would it still look like the cup? No. What does a liquid do that a solid doesn't, boys? What does a liquid do, Joseph, when I pour it on the table? Good job. It takes the shape of the container. So if I want to measure the volume of a liquid, I'm still measuring how much space it takes up, but I can't use a ruler. So the definition of a liquid volume is the amount of space something takes up. How big is it? How big it is. In what type of instrument? Let's find out. The amount of space something takes up. What is the name of the instrument that we're going to use for liquid volume, Evan? Look on Sophie's desk. She has the instrument. What's the name of that instrument we're going to use? It is a graduated cylinder. The graduated cylinder. Anybody know why it's called graduated cylinder? You ever hear the word gradual? What does that mean, Sierra? How about graduation? In your head, you know when you graduate, you finish school. But do you graduate the minute you walk into school? No, when you walk into school, you start in kindergarten. Then you go to first grade. Then you go to second grade. You gradually finish your education. What increments is our education? We measure graduation in terms of grades, and each grade takes how long to complete?
11 months.
Jack. How long does each grade take? Almost. Brielle was almost right, but she likes to call out. Justin. Well, it's 180 days, and we could call it one school what, Jalen? A school year. So a graduated cylinder is going to gradually measure the liquid in increments. Each graduated cylinder has a different scale. If you went to school in Europe, they don't have grades like us. They have key stages. Key stage 1, key stage 2. They measure their graduation differently than we do. When you go to college, you're a freshman, a sophomore, a junior, and a senior. There are 4 stages. Then you have a master's and a post-master's degree. You can get your PhD. There are different stages. When you measure the clock, our scale is based on 60 minutes, right? When we measure in the metric system, everything's based on a unit of 10. So you need to figure out what the graduated cylinder measures in. We know the unit for regular volume. When I measure length, I measure centimeters. If I measure width, I measure centimeters. And I measure height, I measure centimeters. So altogether, when I multiply them, what's the unit for regular solids? For the volume of a regular solid. What would the unit be when I want to put a little label at the end, Adrian? For a regular solid. If you need a hint, go to page 7. When I measure the volume of a regular solid, what's my unit? You labeled it. Centimeters what? Cubed. Good. So if centimeters cubed is volume of a regular object, Sophie, read what the unit is for liquid. Milliliters. We're going to use milliliters for the liquid. Milliliters. It's a little bit different. Do you remember what 1 millimeter was compared to a meter, Joseph?
It was 1,000 times smaller.
1,000 times smaller. So a milliliter is equal to 1,000th of a what, Jack? Of, look for the root. Liter, good. Capital L. We're going to write milliliters, little m, big L. Every time we measure in science class in 8th grade, we're measuring to the nearest what? Measuring to the nearest what, Evan? 10th. When you go to chemistry in high school, or even earth science, you might measure to the nearest 100th. When you measure eccentricity, you're going to measure to the nearest 1,000th. So you need to listen and read the directions. Here, we're measuring to the nearest 10th because our rulers only measure millimeters and our instruments only measure to the nearest tenths. So we can't get any more exact. This statement says 1 centimeter cubed. We know centimeters cubed is volume. So what is that equivalent to if I need the volume of a liquid? What is 1 centimeter cubed equal to? It's also the same thing as what, Amelia? How do I measure the liquid volume? A milliliter. 1 centimeter cubed is equal to 1 milliliter. They're the same thing. So if you have 1 cubic centimeter, you have 1 milliliter. That's the same exact measurement. So if you make a mistake and you write centimeters cubed at the end of something and its volume, you're okay. You didn't make a mistake. You used the one for the ruler. And if we were really super strong, we could take those bonds, those intermolecular bonds of the liquid and force it into a shape of a cube. That would be centimeters cubed. You can pour water into a cube, right? So 1 centimeter cube is equal to 1 milliliter. Water has 2 properties. We learned this last week. It has a lot of properties, but 2 properties we learned last week is adhesion and cohesion. Cohesion, the hydrogen bonds stick together. Adhesion, the water molecules stick to the cup, or in this case, we're going to use a graduated cylinder. And when it does that, it makes a slight curve. This little curve is called the meniscus. It's the curve the water makes because it sticks to the side. It's the curve the water makes when it is attracted to the plastic. Now, in our class, we have plastic cylinders. They don't have large meniscus. But if we had a glass one, the meniscus would be a lot more defined because water is more attracted to the glass than it is to the plastic. It's the curve the water makes when it sticks to the cylinder. So a lot of times you might be confused when you have to measure because if the water line goes up, there's an empty space in the middle. We can't measure that empty space. We can only measure the bottom of the meniscus. And you want to make sure you are eye level to your instrument. So you bend over. So you must read the graduated cylinder at eye level, especially if you're making a cake. If they say put a cup of sugar in it and you didn't measure it eye level, you might have too little sugar or too much. The biggest problem, sugar is not going to be that much of a difference, but if they say baking soda or baking powder, that will mess up your cake. At eye level and at the bottom of the meniscus. This is where our scale comes into place. Every graduated cylinder is different. It depends on how big they are. If you look in the back of the room, there's beakers back there. Look back there by the sink. They're different size graduated cylinders. When you get to high school and college, you're going to be looking at pipettes. They're going to be a little bit different. You're going to be looking at burettes, and their scales are a lot different because we want to be exact. When you titrate something, you want a really small amount, so you have to make sure that it's a very skinny column. The one that Sophie has on her desk is a big column. It's a little bit thicker than the one that's on my desk up here. So the scale is a little bit different. The bigger the graduated cylinder, the bigger the scale. So let's look at letter A. You see the numbers. It starts at 0. We're counting by what? Tens. However, the graduation is not 10. Each little line is a little bit smaller. There are 10 lines in between. So make an inference. What does each line represent? If I'm starting at 0, going to the number 10 up here, let's count. Am I counting by twos? 2, 4, 6, 8, 10, 12, 14, 16, 18, 10. Nah, that's not how you count by twos. What would the number be, Catherine, to get to the top? What number is each line going to be? What am I counting by? You're going to count by... Good. Say it louder. Count by what? Thank you. The next scale is a little bit bigger. Jonathan, when I count by ones, each one of these lines is 1. So I start at 0. 1, 2, 3, 4. That's 5. 6, 7, 8, 9, 10. I know that my scale, I'm counting by ones. Is this the same scale here? I have 0 and I have 10. There aren't 10 lines in between. So my scale is a little bit different. How do I count for the next one? Jonathan? Exactly. I'm counting by twos. Now, the bigger the pipette, the bigger the graduated cylinder, the bigger the scale. The smaller the graduated cylinder, the smaller the scale. So I have some of them. The smallest one I have counts by tenths, like the ruler. And then I have some of them that count by hundredths. So on the bottom, there are 4 examples. There's only 2 different scales. And then you have this page on the next page that will give us the scales as well. I'm going to stop this video when we're done with these. Let's do these together, and then you can practice the page in front of you by yourselves, and then you have plenty of time, so you're not going to have homework. Isn't that wonderful? Okay, first problem. Let's look at it. That's 20. That's 30. What are we counting by, Talin? Good. So tell me what the answer is for the first one. Isabella. Oh, be careful. Is it bigger than, this is in between, is it in between here, 30 and 40? That would be 35. So it's in between there, 25. That's naked. Somebody put clothes on it for me. Go ahead, Ava.
25.
You could put centimeters cubed, but we got liquid now. So I want to change my unit. Liquid volume is what? Milliliters. Small m, big what, Justin? Thank you. Ayami, do the next one. It's in between which 2 numbers? On your yellow paper. Go ahead. Good. It's in between 20 and 40. Be careful. 20's here, 40's here. So what is our number? Yeah, the second one. Okay, if this is 35, what do you think the next number is? 36, and I'm going to say 37. It's closer to the 37. This is naked. Put some clothes on it, Joseph DeMeo. Thank you. Milliliters. You need to make sure you also have the 10th spot. Amelia, do the third one. The smaller the graduated cylinder, the smaller the what? Scale. So this scale's a little bit smaller. You are amazing. 5.5 what? Milliliters. Yes. And the last one. What do we got? Go ahead, Justin.
15 milliliters.
Good, you're naked. Thank you. 15.0. Okay, first page, please finish. What to do?